Okay, so hopefully you've completed the chemical nomenclature practice assignment and now are checking your answers or using this video, however your study needs are best met. But before we get into the assignment, these are the things that I would have with me when I was doing this assignment. Of course, in my head, that question, is there a metal? Do we know its charge to separate these three major categories? If there's a metal, it's going to be an ionic species. And if it does have a metal, do we know its charge is going to tell us whether we need to tell what its charge is using the parentheses and the Roman numerals. If not, we just take the anion's name and we put the suffix "ide." We do that for both cases. If there is not a metal, then we're going to be only then using those Greek prefixes, except in the case when the first element only has a single one, and we would drop the mono in that case. And again, we're going to use the suffix "ide" for the second element. I'm going to want to make sure that I have my periodic table and I know what metals, what are metals, what are not metals on the periodic table, and what the charges for those alkali metals and silver +1, alkaline earth metals, cadmium and zinc +2, and aluminum +3. I'm going to want to have a list of all the polyatomic cations and anions. These, of course, are not all of the polyatomic cation and anions that exist. There are countless of them. These are common ones that are used that you'll see in tests. We're going to want to have the rules for acids. When we see an H plus as the cation and that aqueous symbol, we know that we're dealing with an acid. Binary acids are those when the anion is a single element or a polyatomic that does not contain oxygen. Oxo acids are when the anion is an oxyanion. We have two choices then, an oxyanion that ends with "ate" or an oxyanion that ends with "ite." And those oxy acids will become ic or os acids, always with that word acid after. And these are the different applicable ates and ite polyatomic oxo anions. And then don't forget, and there was a review assignment to make sure you practice this, but when we're putting ionic species together, the charges must sum to 0. So we're going to use that to deduce the charge on a species like iron. Here is iron 3+ because of the 3 2- oxygens that are with it. We can also figure out how many polyatomic species, for example, may need to be balanced with a certain metal. So this knowledge about how the different charges must sum to 0 is going to inform our nomenclature steps going forward. So with all that information in front of us or in our head, let's go. So is there a metal? Nitrogen and hydrogen, no. So we're going to be using our prefixes. The prefix for 2 is di. The prefix for 4 is tetra. So this is dinitrogen, tetra, hydride with the suffix "ide. Dinitrogen, tetrahydride. All right, we're off and running. The next one was this species, starts with hydro and ends with acid. So that's going to be an acid. Start with H, end with aqueous. We know that to be true, just of an acid. The fact that it's a hydro acid means that it's a binary acid. That tells us that the polyatomic, or I'm sorry, the anion species, if polyatomic, does not contain oxygen. But in this case, it's bromic, which is simply the bromine Br minus anion. So this is HBr, hydrobromic acid. Is there a metal? let's see. Yes, Mn, manganese, that's a metal. Do we know its charge? Manganese is a transition metal, and it's not silver, cadmium, or zinc, so we don't know its charge. CrO4 is, we go to our chromate. CrO4, 2 minus, is chromate. I won't go to the polyatomics every time, so make sure that you have your list in front of you, but this is chromate. And with the polyatomics, we're just going to put the name in. So the only thing that we need to know is what's the charge on manganese. Well, if chromate is always 2 minus, then it's going to have to balance with a 2 plus charge on manganese. So manganese is going to have to be 2 plus for only one chromate to balance out the charge. So this species will be called manganese, parentheses, 2 for the charge on manganese, chromate. Is there a metal? Yep, K. Potassium is a metal. K, do we know its charge? Yeah, K is always 1 plus as an alkali metal. We have 2 of them for a 2 plus charge because they're balanced with an oxide, which is always 2 minus. So our 2 plus equals our 2 minus. K2O, for a metal, an ionic species, we put the metal's name. Do we know its charge? Yes, it's 1 plus always. And so we don't need the Roman numerals. We'll just put the anion's name with the suffix "ide." So oxide, potassium oxide. Good job if you got it. Tin, IV, sulfate. So 1 before V, which is 5. 1 before 5 is 4. For those of you that are not Roman, the Roman numeral 4 is IV. So that 4 is the charge on our cation. That's what the parentheses in Roman numerals mean. It's important to keep that straight. So tin with the elemental symbol SN must be 4 plus. That's what this information here is telling us, is that tin 4 plus exists, and with it, it's associated with sulfate, and sulfate is SO4 2 minus. So for our 4 plus to equal, it's going to have to equal 4 minus, and to achieve that, we're going to need 2 sulfates, SO4 2 minus. And so the formula for tin 4 sulfate, excuse me, would be SN. We just need one of those species. And then we're going to need 2 sulfates. So open parentheses, SO4. And we'll need 2 of them. 2 sulfates for the 4 minus to balance out with the tin. Okay, well, we're starting with an H. Is there a metal? No. Is the cation H plus? Yeah, it is. And there's an aqueous sign. So to us, this screams acid. Where the acid makes its H plus, it separates from an anion that's a polyatomic species with oxygen. So this is an oxo acid. So an oxo acid, we're not going to put hydro. We're just going to start right off with the name of the polyatomic oxo anion. In this case, it's nitrate. Nitrate ends in 8, and 8 becomes ic. So this is nitrate, nitric, and then the word acid. Nitric acid. So we identify it's an acid. We identify the anion. We see that there's oxygen. Identify the polyatomic anion's name. Change the 8 to ic, nitric acid. Lithium bicarbonate. Is there a metal? Sure, lithium, it's right there. Lithium is always 1 plus. Bicarbonate is 1 hydrogen on carbonate or hydrogen carbonate. It's HCO3, 1 minus. Carbonate's 2 minus. Bicarbonate, when you put 1 hydrogen on, takes one of the negative charges away. So bicarbonate is just 1 minus. And as a result, we only need 1 bicarbonate and 1 lithium to make a 1 plus, 1 minus, have our charges sum to 0. And so we have lithium HCO3. No parentheses needed. 1 lithium, 1 bicarbonate. Thank you very much. P2O3. Is there a metal? Nope. Phosphorus and oxygen, no metals. And so we're going to use prefixes. Does the first non-metal have only 1, so we can drop the mono? Nope. We have 2, which is di, and 3, which is tri. And so use our prefixes diphosphorus, trioxide. Diphosphorus trioxide. Nitrous acid, so it's an acid from the word acid. It's going to start with H and it's going to be in the aqueous phase, that we know. It doesn't start with hydro, so it's not a binary acid. This is an oxoacid. Oxoacids are really just the name of their anion. But if it ends with 8, it becomes ic. If it ends with ite, it becomes os. So this is nitrite. It's the acid that's made with nitrite. Nitrite is NO2 minus if we look at our polyatomic species. NO2 1 minus is only going to need 1 H plus to counter out its charge for them to sum to 0. So this is going to be HNO2 aqueous, nitrous acid. Calcium nitrate. Is there a metal? Yeah, there's a metal. Of course, it's calcium. Do we know its charge? It's always 2 plus. Alkaline earth metals. Nitrate, non-ide, it's an 8. 8 ites, those are oxoanions, and nitrate is NO3, 1 minus. So if we have 2 plus and 2 minus, we're going to need 2 nitrates to make 2 minus altogether so that the charges sum to 0. So we're going to have 1 calcium, and this time we'll need parentheses so that we can register 2 NO3 1 minuses, 2 nitrates to balance the charge of our 1 calcium. PBr5, is there a metal? No, not this time. Phosphorus and bromine. So we're going to use the prefixes. The first one is 1. And so it would be mono for 1, but because it's the first one, we'll drop the mono. And 5 is penta, like the 5-sided pentagon. So we're going to drop the mono on our first species, and it's just phosphorus, penta, and bromine with the ide, bromide. Phosphorus, pentabromide. Copper 1 sulfite. So what this means is that we have copper, Cu, and it is 1 plus. The copper has a 1 plus charge. That's this information, the parentheses here. And sulfite, SO3, 2 minus. Sulfite has one less oxygen than sulfate, but the same charge. So sulfite and sulfate, both 2 minus, but sulfate SO4, 2 minus, sulfite SO3, 2 minus. Sulfite is what we're using. So we have our sulfite SO3, 2 minus. It's going to need 2 plus to cancel out so that the charges sum to 0. So we're going to need 2 copper 1 pluses. So copper 1 sulfate would be Cu2 SO3. Calcium and iodine. So is there a metal? Yes, calcium. Do we know its charge? Calcium's always 2 plus. It's an alkaline earth metal. So we don't need the parentheses to tell the charge of the cation. We just write its name, calcium. No parentheses needed, iodine, and we change the suffix to "ide," iodide. Iodide, calcium iodide. Fe2 minus, is there, I2, excuse me, is there a metal? Yes, iron. Do we know its charge? No, it's a transition metal, but it's not silver, cadmium, or zinc, and so we don't know its charge always. We know that iodine is iodide, a halogen that always gains 1 electron to form I minus, and there's 2 of them, making a 2 minus charge. That 2 minus charge must balance out with a 2 plus charge. They must sum to 0. And there's only 1 iron to do that job. So that means that iron must be 2 plus for it to cancel out the 2 I minuses that we get from the I2, which means that the name of this species is iron. Is there a metal? Yes, name it. Do we know its charge? No. So put parentheses, in parentheses, put Roman numerals that equal the charge of the metal. It's 2 plus. So it's iron 2. And then the non-metal iodine with the suffix "ide," iodide, iodide. Is there a metal? Yes. Do we know its charge? No. So we write it in from deducing it from the anions, which it's 2 plus, iodide. Hypochlorous acid. So we have an acid, so we know that we're in acid nomenclature territory. It's going to start with an H. It's going to end with an aqueous. Does it start with hydro? Yeah, wait. Oh, wait, not hydro, hypo. Hydro, are those the same? No, they're not the same. So it does not start with hydro. So that means it's an oxo acid. Oxo acids just give us the polyatomic oxoanion's name, but we change the suffix to "ic" if the original suffix was 8. We change the suffix to "os" if the original suffix was "ite," and nothing else. And so we see that there's no hydro, so it's an oxo acid with the suffix "os," so the suffix must become "ite." So this makes this polyatomic oxoanion hypochlorite, which is ClO minus from our polyatomic table. So hypo and hydro seem similar, but they are not. So this is the acid that's associated with hypochlorite, which is 1 minus. So we'll only need a 1 plus hydrogen for the 1 minus to equal the 1 plus. So HClO is hypochlorous acid. WO3 or woo. There's my little joke. Sorry. Is there a metal? That's a tough one. Is it W? Yes, it is a metal. It's a transition metal, tungsten. Remember, those symbols can be different than the English name. Tungsten W. Do we know its charge? No, we don't know always the charge of tungsten. So we'll go to the oxide. Oxygen is always O2 minus because it's in group 16 or 6A. And there's 3 oxygens here. So O2 minus, O2 minus, O2 minus for a 6 minus total, which has to be balanced with 6 plus charge because the charges will sum to 0. And that 6 plus charge is distributed between 1 W or 1 tungsten species. So that 1 tungsten must have lost 6 electrons or be 6 plus to be able to balance its charges with 3 oxides O minus. So this is, put the name of the metal, tungsten. Do we know its charge always? No, so we need parentheses. Those parentheses must tell us the charge that's on tungsten, and for it to cancel out 3 oxides, it must be 6 plus, or Vi, 5 plus 1, 6, and oxide, the suffix "ide." Tungsten 6 oxide. Is there a metal? N2O? No, there's not a metal. So we're going to be using the prefixes. Nitrogen, there's 2 nitrogens, so we'll be using the di prefix. 1 oxygen, so we'll be using the mono prefix. Now remember, we only drop mono when it's the first species is mono. If the second species is mono, we keep it, or subsequent species, if they're mono, we keep it. So we're going to use the prefix di and then the element's name, nitrogen, and then mono, oxygen with the suffix "ide", so monoxide. Dinitrogen monoxide. Rubidium sulfate. So rubidium, is there a metal? Rubidium is an alkali metal with the symbol Rb. Alkali metals are always 1 plus. They form 1 plus cation. So is there a metal? Yes. Do we know its charge? Yes, we know its charge because if we didn't know its charge, we would see Roman numerals in parentheses in between the metal and the anion. We don't see that in this species, so we know we should find this metal as an alkali metal, alkaline earth metal, or cadmium, silver, zinc, or aluminum. So 1 plus rubidium sulfate is SO4, 2 minus. So we're going to have a 2 minus charge here. We're going to need 2 plus charges so that the charges sum to 0. So we'll need another, excuse my errant hand, another rubidium, which is Rb, plus 2 rubidiums with our 1 sulfate makes Rb2 SO4. Rubidium sulfate, Rb2 SO4. So we have the aqueous and the leading hydrogen, both symbols that we're dealing with in acid. This is a binary acid because when we divide it, we're going to get chlorine Cl minus, not an oxo anion. And so we're going to be using the binary acid rules for nomenclature, which we will start with the prefix hydro. Then the root of the anion, which is chlorine, the root plus the suffix ic, so hydrochloric, and then the word acid. So this binary acid is hydrochloric acid. Dinitrogen monoxide. So the mere presence of prefixes should remind us there's no metals here because we only are going to be using the prefixes when the answer to the question, is there a metal, is no. So here we use prefixes, di meaning two, mono meaning one. So di, two hydrogens, H2, mono, one oxygen, dihydrogen monoxide, H2O, aka water. That's my little joke. SRS. So SRS, SR is strontium. Strontium is an alkaline earth metal, which always forms an Sr2 plus cation. So is there a metal? Yes. Do we know its charge always? Yes, it's always 2 plus. So no need for parentheses, no need for the Roman numerals to tell us the charge of the cation. And because there's a metal, no prefixes. So we'll just put the name of the metal first, strontium. No parentheses needed. Sulfur turns into the S2 minus sulfide. That's why there's one of each of them. Their charges sum to 0. This is strontium sulfide. Carbonic acid. It's an acid because of the word acid. There is no hydro, so it's an oxo acid. Oxo acids change the suffix to ic when it starts as ate. It changes the suffix to os if it starts as ite. This is ic. So this polyatomic oxoanion must have originally had ate as the suffix. So it was carbonate. This is the acid that forms from the carbonate CO3 2 minus oxoanion. If we have a 2 minus oxoanion, we're going to need 2 H pluses to form our 2 plus to cancel our 2 minus or to sum to 0 with our carbonate 2 minus. So carbonic acid will have the formula H2 CO3, and of course aqueous because it's an acid. Leading with H and aqueous because it's an acid. The oxo acid formed from carbonate CO3 2 minus. Okay, so we have lead. Is there a metal? Yes, it's lead. Do we know its charge? Lead is a post-transition metal. It's element 82. We don't know its charge always. So it is found with acetate here, C2H3O2, and there's two of them. Acetate is 1 minus on its own. And so if we need two of them, then there's going to be a 2 minus charge from the anions. That's going to be countered with 1 lead Pb, and that must be 2 plus to counter the 2 1 minus acetates. So this lead, the name of the species is lead. Because we don't always know its charge, we're going to use the parentheses and the Roman numerals for 2 plus, which is 2. And then the polyatomic named acetate and no changes to the suffix. So lead-2 acetate. Lead-2 acetate. CDF2, is there a metal? Cadmium, yes. Do we know its charge? Actually, yeah. Cadmium is one of the few transition metals with silver and zinc that we know the charge always. Cadmium is always 2 plus. And it is countered with 2 fluorines, which are halogens that are always 1 minus, which is what gives us our 2 minus. And 2 plus summing to 0. So is there a metal? Yes, we name it cadmium. Do we know its charge? Yes, so no need for the parentheses and Roman numerals. And then we use the anion with the suffix ide. So this is cadmium fluoride. Is there a metal? Yes, titanium. Do we know its charge? Titanium is a transition metal we don't always know its charge. So we look to the fact that there's two fluorines, which are always 1 minus, telling us that that fluoride would be 2 minus altogether. The one titanium present must counter that 2 minus charge with a 2 plus charge, so the charge is summed to 0. That 2 plus charge is encapsulated completely on the titanium, the single titanium element, which must be titanium 2 plus. So the name of this species, we name the metal titanium. We put the parentheses to tell what the charge of the titanium is. It must be 2 plus because it counters the 2 fluorines, which become fluoride. Titanium 2 fluoride. All right, moving along. Is there a metal? No. Sulfur and oxygen, no metals. So we're going to go to our prefixes. 1 sulfur is the mono prefix. 3 oxygens is the tri prefix. But if the first species has a mono as a prefix, we can drop it. So we just put the element's name, no prefix, sulfur, and then trioxide. We'll use that ide suffix, sulfur trioxide. Carbon tetrachloride. So no metals here. The presence of prefixes tell us that there's no metals. We've dropped the mono because apparently there is 1 carbon. Carbon times 1. Tetra is 4 times chlorine with the suffix ide. So 4 chlorines, or sorry, not in this case, it's just chlorine, no negative charge. And so our formula would be carbon and 4 chlorines. 1 carbon and 4 chlorines. Carbon tetrachloride. Is there a metal? Yes, K. 2 of them, actually. Do we know its charge? Yeah, K is always 1 plus. Cr2O7 is dichromate. And that's always 2 minus. So no need for parentheses and to tell us that the charge of potassium is 1 plus. We always know that it's 1 plus. So we simply write the name of the metal, potassium dichromate. And we see that di prefix, but that is actually in the name of the polyatomic ion. I'm not using the prefix here. So this polyatomic species is named dichromate just to be confusing to students. So it is a species that is associated with a metal, but has the prefix in the polyatomic species as potassium dichromate. Cobalt 3 cyanide. So cobalt 3 here, what that tells us is that we have a metal in cobalt. We don't always know its charge, so we need to tell that the charge is 3 plus with the Roman numerals. And it's associated with cyanide, which is Cn minus. We know that the 3 plus must be balanced out with a 3 minus. And so we're going to need 2 more cyanides, 3 cyanides total to balance out the charge coming from the cobalt 3 plus. And so we'll have our cobalt, we'll need parentheses, Cn, and 3 of those cyanides to have cobalt 3 cyanide. HNO2 aqueous. So we have our acid here, known from the fact that it leads with a hydrogen cation and the aqueous symbol is present. So when we separate our H plus in our acid, it's going to have an anion that's an oxo anion NO2 minus. That is our nitrite. Nitrite oxoanion. So when we have an oxo acid with ite, the ite becomes ose. So no hydro with the oxo. We just take the name of the oxoanion. And if it's ate, becomes ic. If it's ite, it becomes ose. So this is nitrite, becomes nitrose. Nitrose. And then the word acid. Nitrose acid. Nitric acid is HNO3 with nitrate. Nitrose acid is HNO2 with nitrite. Dinitrogen trioxide. The presence of the prefixes tell us that there's no metals. Di is 2. Tri is 3. So we're going to have 2 times our nitrogen and 3 times our oxygen. So this formula is N2O3. PbCO3. So we have, is there a metal? Yes. Lead. Do we know its charge? No, we don't always know the charge on lead, but it is associated with one carbonate, which is always CO3 2 minus. That 2 minus must sum with a 2 plus. They must sum to 0. And that 2 plus charge is on a single Pb element, one atom. Pb must be 2 plus for it to sum to 0 with a carbonate 2 minus. So that makes this lead. We don't always know its charge, so tell me what it is. It's lead 2 carbonate. Okay, is there a metal? Nitrogen, selenium? No, there's no metal, so we're going to be using prefixes. Our first prefix is tetra, not mono, so we won't drop it. Our second prefix will be for 2, which will be di. So this species is tetra nitrogen. And then di selenium with the suffix "ide." Selenide. Diselenide. Is there a metal? No. We've got carbon and oxygen. Neither is a metal, so we're going to be using prefixes. Mono for the prefix for 1 carbon. Mono for the prefix 1 for the oxygen. But if mono is on the first element, we drop the prefix and we just put the element named carbon. And then monoxide. Monoxide. This is carbon monoxide, that gas that we don't want to build up too much in our house. Otherwise, it will help, stop us from breathing and living. So carbon monoxide. And that's the end of the nomenclature naming compounds practice worksheet or assignment. So hopefully you went through that and understood how to get the different names for the different molecules and ionic compounds and acids that may come up in your different chemistry and general chemistry classes. All right, thank you very much for your attention.